What if I told you that the most powerful tool in science isn't some supercomputer or a fancy lab, but just three simple words? I don't know. Today, we're diving into why admitting uncertainty isn't a weakness. It's actually a scientific superpower. You know, we're all taught to think of science as the place we go for hard facts and solid, definite answers. But what if the most crucial, life-saving answer a scientist could ever give is simply, we're not sure? It sounds strange, right? But that little phrase is way more powerful than you might think. All right, so first up, we're going to question what we even mean when we say we're certain about something. Let's look beyond a reasonable doubt and really challenge our own assumptions about how sure we can be, even when science is involved. I mean, think about it. If you're a safety inspector at a nuclear plant, or you're sitting on a jury, you want a clear yes or no, right? Is it safe? Is the evidence 100% conclusive? But the reality is, science usually works with probabilities, not absolutes. And that's where things get really, really interesting. And this leads us to a concept called critical uncertainty. Now, this isn't just some academic debate. It's a very specific gap in what we know, a gap that can have huge real-world consequences. We're talking everything from major financial losses to, life or death situations. So what does this look like in the real world? Well, to see this critical uncertainty in action, we're going to look at a case where the evidence is hiding in plain sight on something you might even have in your wallet right now, a banknote. You'd think that testing a dollar bill for something like, say, trace amounts of drugs would be a pretty straightforward open and shut case. But as you're about to see, the story that a single banknote can tell is anything but simple. In fact, it's complicated. Just think about it for a second. How many people have touched a single bill? Hundreds? Thousands? There's no way to know. And that's the problem. It's almost impossible to say for sure if any trace substance is from some illegal activity or just from all the random stuff that happens in everyday life. You can't just find a perfectly clean banknote that's been out in the world to compare it to. It doesn't exist. And that's the whole point. If we can't be absolutely certain about something as common and everyday as a banknote, just imagine how much more complex other kinds of forensic evidence can be. This is just the very tip of the iceberg. Okay, now let's seriously raise the stakes. We're going to move on from microscopic traces on a piece of paper to a situation where not knowing the answer could have literally explosive consequences. When you're taking apart an old nuclear reactor, you come across this stuff called graphite dust-air mixture, or GDAM for short. And when you find it, there is one incredibly important question you need to answer. Is this stuff explosive? You'd really hope the answer is a simple yes or no. But this is where things get really weird. Get this. In a small 20-liter test chamber, GDAM explodes, and I mean violently. But then, when they test the exact same substance in a much larger chamber, one that's closer to real-world conditions, it doesn't explode at all. Nothing. The same exact stuff gives you completely opposite results. How is that even possible? As one expert report puts it, quote, "There is no clear answer to the question on the explosibility of GMADM. That sentence right there is the very definition of critical uncertainty. And let me tell you, when you're dealing with a nuclear facility, we're not sure is a terrifying answer. The stakes just don't get any higher. And this isn't some one-off thing that only happens with nuclear reactors. These kinds of high-stakes unknowns are everywhere. Like in mining, how can you know for sure the maximum explosive size for ore dust if you don't have all the data? Or in super advanced manufacturing, how is a certain kind of graphite going to behave under intense pressure? These are the kinds of questions that keep engineers up at night. So we've talked about justice, we've talked about safety. Now let's talk about something we can all understand, money. Because it turns out not knowing something can be an incredibly expensive problem. When you're running a gigantic mining operation, every tiny bit of efficiency matters. A huge part of the whole process is just crushing rock to get to the good stuff inside. It doesn't sound very glamorous, but the physics of how that rock breaks apart is, quite literally, a million-dollar question. See, here's the problem. If you don't understand exactly how that rock is going to fracture, you end up creating way too much useless, superfine dust. That dust isn't just a waste product, it's profit, literally turning to dust and blowing away in the wind. It's money just vanishing. So that gap in knowledge, that little bit of uncertainty about how a particle of rock will behave under pressure, can end up costing a single mining company millions upon millions of dollars. It's a pretty powerful reminder that what you don't know can absolutely hurt your bottom line. Okay, so we've looked at banknotes, nuclear reactors, mining, all these cases where we just don't know for sure. It might be tempting to think, wow, science is failing us. But here's the big twist. This uncertainty, it isn't a bad thing. In fact, it's the key to everything. And this is the most important idea I want you to take away today. Recognizing and admitting uncertainty isn't a failure of science. It's the fuel. It is the very engine that drives progress, pushes us to ask better questions, and helps us discover what's next. You see, when we admit we don't know, it becomes our superpower. It stops us from being dangerously overconfident. It forces us to create safer rules, like treating GDAM as if it's always explosive, just in case. And most importantly, it's the humble beginning of every single breakthrough in human history. Every great discovery started with somebody being brave enough to just say, I'm not sure about this, but I'm going to find out. So, as we wrap up, I want to leave you with one final question to think about. Forget about science for a second, and just think about your own life. What's one thing you are absolutely 100% certain about? And what might happen if you let yourself question it, even for a moment, with a little bit of that powerful, healthy dose of, I don't know?